Right? This is second part of general arrangement. So if you have a, what can I say? If you are interested in cars, you may see the silhouette or front or back side. You can identify which car it is. Similarly, if you have experience and interest in ships, and then you can identify which type of ship by seeing the silhouette. Maybe sailing yacht is easier, right? Cruise ship, maybe not. Bulk carrier. You see that this is very shallow because they carry heavy items, such as iron or coal or sometimes grain. So that heavy, so that the ship need to have a bigger displacement, the buoyancy. And then when cargo is loaded, ship is down. But for the cruise ship, you need to have a more hotel rooms and with a good view in high floor, high store, high height. That's why the ships goes higher and higher to have a more hotel facility. Rather than, and then the weight of the cargo is mostly human and human belongings. That is very not heavy, light. That's why the buoyancy force is not so much needed. So that draft, the submerged part is usually small. And then instead, the height is over water is high. So one kind of problem like this one here is stability. Stability is not good comparing to this one. So you should be more careful about this. And for Korean students, the Sewol ship is a kind of cruise ship, Ro-Ro cruise ship, and also car carrier. That's why it has a higher figure above the water, and then the stability was not. Research ship is for the ocean scientific observation something. Research ship for the research people for ocean biology, ocean chemistry, ocean something. They are trying to observe and examine the ocean itself. The yacht is two kinds. The sailing yacht is you need to have sails, and motor yacht is do not need a sail. And bulk cargo is something like this one. This one is used for nowadays for power plant and also steel making company. That is, I remember that is the most mostly for the power plant. But nowadays, because of the environmental issues, people are trying to avoid to using coal for the power plant. But still, this is very good source and cheap source for power plant energy. And this is kind of another food in bulk. If you go to store to buy some food, your food, many of them are now covered and separated out as a single unit and measured and also pay by cover, right? But special food like this one, you need to have a special measure. There is no same unit sized packaging like this. You need to have a special and then something like this one. And so we call this is a bulk items, and bulk cargo is same similar property like this. And this one is a container ship. MOL is one of the famous container shipping company name. And you know that there are so many containers stacking up above the deck. So also the container ship usually tend to have high floors, but they say the cargo inside is relatively heavy, not so heavy like the coal or iron, but still middle size heavy, medium size, so that the buoyancy force also needed. So it's a balanced one. And they are saying probably cargo weight, something like that, is 54,000 ton, and length is 294 meter, and breadth is 32.2 meters. This number is very special. The breadth of 32.2 is special. We call this Panamax ships. Panamax is there is a Panama Canal between North America and South America. There's a country called Panama. They have a canal, and so that when the ship from New York is want to travel to the Los Angeles, they shoot down to the Panama and goes through the Panama Canal. And then canal has a limitation for size. Usually the most important limitation is breadth of the canal. And that allows, this is a maximum breadth. So we call the Panama maximum, Panama maximum, the Panamax class or style ships is very popular in all days. But as ships are going bigger and bigger, the Panama country decided to expand that canal. So nowadays, the maximum size increased to 50 meters. It was about 5 years ago, not so. So very new, relatively new expansion of Panama Canal. And then this is a draft. Draft is depth below water level, 13 meters something. And container amount is 4,000 TEU. Is as I tell you before, that 20 equivalent unit, so 20 foot. It's like this is all 40-foot containers. There is 20-foot container. No, just that. So 40 feet container should be 2 TEU. And this one is a large container ship. And this is a concept design only. Probably they already built some of them. But at the time, this was only drawing or design only, not built. So length is about 2 times before, larger. Also, this breadth is also 40 meters. So maybe this one cannot pass through the new Panama Canal. Anyway, the cargo capacity, oh, sorry, this is, but anyway, 13,000 TEU, much larger. The previous one was 4,000, 4,000. 4,000. And bronze was 32, but only 40% something increase. Then the number of TU is 3 times more. And speed is not 25, but it is in kilometer per hour is bigger than the number. And double skin fuel tank means fuel tank can be break because of the sometimes accident like a collision. Then it can create a pollution of the ocean. So that many times they have a two-plate double skin, two-plate, twice covering to protect them the pollutant chemicals are coming. Yeah, where is it? Let's see. Yeah. Cargo operation.
Let me show you how containers work. It's possible that most things around you right now came from a container ship. The food you ate, the phone or computer you're looking at. We have anything from apples to frozen meat to explosive or toxic gases on the ship. Some of the things we carry is pretty bizarre. But everything actually begins in the office with a team of people we call central planners. They drop cargo plans for the whole supply chain. Then it's sent to a chief mate to adjust as required. The containers are loaded by port's crane. Some say they were used by the Empire. Starting from the bottom, stacking up like Legos. These cargo holds can be as deep as 40 times 40 meters. The spades are built with these long sail guides that run downwards. It secures the containers in place. And this is what an empty container hold looks like. Once it's filled, a hatch cover is placed on top so that more containers can be loaded. The ones above on deck will need extra lashings to secure them. Workers from the port handle the physical labor of lashing. Thank God, because these full metal rods are very, very heavy. Turnbuckles are twisted to tighten the steel rods. For that, we have turnbuckles, short bars, long bars, and twist locks. There's actually a few types of twist locks on our ship. Some are manual, some are automatic. It all depends on the location of the containers, but they serve the same purpose, which is to lock containers. Once again, it really is just like stacking Legos. The fruits and frozen products are transported by reefers. Reefers are short for refrigerated containers. They are pretty much a gigantic portable fridge. It can keep temperatures anywhere from room temperature to -30 degrees. That's -90 Fahrenheit for America folks. So what's my part in all this? Well, as third mate, my job during cargo operation is to monitor the loading and discharging progress. Afterwards, checking the lashing to make sure it's done properly. The last thing we want are containers falling into sea if we ever run into bad weather. Other than that, we keep watch on the overall condition of the ship, including safety and security, checking the mooring lines and looking out for any suspicious activities like stowaways or pirates. So that was a general overview of how cargo operations are done on container ships. If you got any specific questions, make sure to leave it down in comments.
Right. And this one is the ferry ship or cruise ship, you can say. And big size, right? Many floors, and including many hotel rooms and swimming pool too. So it is the length is very long. The big ship, 430-meter length, and the draft is 15. Yes, and breadth is 70-meter. But the weight is only 30,000 tons. And then let's see. No. Same. It is coming from the Japan book. And cruise ship has a placing, say something like 7 is a navigating bridge. There is a captain is located to build the ship engine, and 1 is a public space, probably lounge, bars, and dining rooms. Important. And number 3 is a passenger cabins, and 8 can be a main engine room. And what else? 2 can be galley. Something like that. And bottom, you may find that deck stores, food stores, and double bottom used for fuel stores. Like this. So arrangements, the general arrangement. How do you locate space and use them for what purpose inside the ship? Very similar to building design arrangement, space or location something. So there's another video of cruise ship. See.
What's it like to learn math on Brilliant.org? Brilliant gets you hands-on to help you learn by doing. Learn topics from everyday.
This is the Symphony of the Seas, an 1,188 feet long, 8,880 person, 18-deck, 7-neighborhood beast of a cruise ship that makes the Titanic look like a kayak. It cost $1.4 billion, but cruise ships only last about 25 years. 25 years of constant cleaning and maintenance, plus an enormous amount of food, fuel, fees, and employees. But tickets can cost just $60 or $70 a day, cheaper than most retirement homes, and a bit more fun. So making profit, and quite a bit of it, means optimizing everything, from a ship's flag to its precise schedule. Like airlines, the business of cruising is one of low margins at extreme scale. Cruise lines are experts at finding clever ways to save money. Norwegian Cruises would even sail 1,100 miles into the middle of nowhere to avoid fines. They run a very tight ship. Cruises can be long, short, salty, or not, but they all fall under 3 basic categories. Mainstream cruise lines optimize for scale. They sell lots of tickets for not a lot of money, sometimes even at a loss. The average ticket sells for $1,293, but costs the company even more in food, fuel, wages, marketing, and lots more. If everyone left their wallet at home, these cruise lines would go out of business. But the average person spends $429 on board. They're the perfect captive audience. When your only choices are Pepsi or seawater, they can pretty much guarantee your purchase. Casinos, spas, shopping, and drinks are key to making profit, and why you can't bring your own. And since everyone walks from cabin to dining room at least once a day, that's where they place lounges, bars, and casinos. There's no avoiding them. Premium lines are just the opposite. They make most of their money up front. The no screaming kids on board tax means they can spend more time in ports. And luxury ships may only hold a few hundred passengers, but each pays more than enough to make up the difference. All 3 categories serve very different markets, so a good company catches them all, which is why so many brands are owned by just 2 mega corporations. Carnival owns Holland America, Princess, P&O, and Costa, even an airline at one point. And Royal Caribbean owns Celebrity and Azamara. This way, something like Costa Concordia doesn't damage the rest of the company's reputation. When a ship reaches the end of its life, they can just hand it down to one of their other brands with lower standards. And a cruise ship is a vacation machine, but it can never take a vacation. November to April is when cold Americans escape to the Caribbean, but keeping that many ships there all year round would be extremely costly. So is moving around empty ships from one region to another. So they don't. When Caribbean ships switch to Europe in April, they sell repositioning tickets. A one-way, 2-week cruise from Florida to, say, Amsterdam. This way, the ship is always making money. And when one cruise ends, the next begins. Turnaround is
Okay. Skip to next slide. And this one is cruise ship again. Let's see this one. Restaurant, theater, and the Caribbean, Mediterranean, and Alaska. There is a famous cruise courses. And Panama Canal. Panama Canal. So this one is an old one before the expansion, so that you see that the breadth, maximum breadth was 32.2 meters at the time. So that every ship that want to pass through or want to be big, so they should be keep on the Panama Canal breadth limitation. Right. This one is expansion. Right. Expansion video. So show you.
Panama Canal celebrates 100th anniversary. The expansion of the Panama Canal, aimed to be completed by June 2015, will open up the 81-kilometer channel to even bigger vessels. The canal currently uses locks to raise ships 26 meters above sea level. Water from the artificial lake enters by gravity into locks and causes ships to rise. The ships then travel through the artificial lakes and channels until they reach the locks to the sea on the other side. 2 new sets of locks are being constructed to supplement the already existing locks at the Atlantic and Pacific entrances of the channel. The new locks will be larger but use less water than the existing ones. Nearby basins will recycle the water from the locks as they are emptied and use the water to partially fill the locks when another ship passes through. Water from the canal's lakes will also be used to fill the locks. The new locks will be able to handle ships that are longer, taller, and wider. Per ship cargo capacity will nearly triple, from the current roughly 4,500 standard container limit to roughly 12,000 standard containers. These changes will make the Panama Canal more competitive with the alternative Suez Canal route, which currently accommodates much larger ships.
And this one is ocean energy exploration. So this is kind of drilling ships. And then say drill depths. The height of this drill tower is saying 130 meters. Then what else? So it's coming from Japan, building jump step. Right? And oceanography research ship for the scientific research for ocean. So you can see that there is a what is this? Double bottom and so scientific equipment is here. Scientific equipment. And number 2 is most good place. And then public accommodation, storage. The other things are similar. Here is research vessel. You can see this.
70% of the Earth is covered by the ocean, and the ocean interacts with the atmosphere and the land. Those interactions control the world we live in.
Some of the most important questions facing society includes climate change, the future of food supply, sea level rise, geohazards such as earthquakes and volcanism along coastlines. It's very important to understand the basic scientific underpinnings of all these different processes.
Being able to go out to the ocean and make observations is the most critical component of oceanography. And it's going to rely on new vessels with new capabilities to use the ship efficiently and gain the maximum benefit for the most people.
When we were approached by Oregon State, one of their key objectives was to make this as green a ship as possible. We've gone to great lengths to incorporate the latest technologies into the ship to keep it as environmentally friendly as we can.
We've decided to use variable speed alternators to make electricity. We've also used LED lighting wherever possible. We're using waste heat, so the heat from the engines, we'll use that to heat domestic water and to actually make potable water for the ship.
The design of the ship is very, very important to the efficiency of the ship. And so we went to great lengths to make this as low resistance hull as we could, in keeping with the desires of the scientists to have global sweep down minimized for the performance of their instrumentation.
Part of the design has been to incorporate a U-tube anti-roll tank. And so that means the vessel can operate in more challenging environments. And a lot of our coastal environments do see some pretty severe weather conditions. And we like to be able to investigate ocean processes under all conditions, not just on a sunny day.
We've got a double articulating A-frame, which will allow the vessel to pick up pretty large packages. The launch and recovery system will be designed so that it can put the CTD almost down to level.
Any questions on video? And drill ship, we already see this drill ship, Shikoku. This one is drill ship. Drill ship is drill capacity is important. the depths of drilling. Or 11 kilometers drilled, so very long distance drill. And also dynamic positioning is they want to keeping the position at the ocean level, even though there is a current and wind is blowing and something like that. Otherwise, the long pipe should be break. The dynamic positioning is you use small propellers around the ship and then control together to make that positioning. And also you need to have a GPS to check your position. So it's a controlled and ensemble the way of controlling. And this is a deep sea drilling video. Okay. See the drilling, how the drilling is working.
This is you preparing for a date on a fine evening. Then this guy says, "Mind if I tag along?" This is a skin tag.
Name of the ship.
How does the deep-sea drilling vessel Chikyu drill into the seafloor? When the vessel arrives at the drilling site, it receives a satellite signal that helps the vessel move into the exact position required. The vessel has 6 propellers that rotate a full 360 degrees and keep the vessel in one position, preventing it from drifting due to the wind, waves, or sea current. First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and guide are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is led down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The Chikyu is equipped with the riser system in order to drill into the earth even deeper. As the riser pipes are added one after another, the blowout preventer run down to the seafloor.
FPSO, you see before it is a picture of FPSO, but it's floating production and storage and offloading. And then this is a very complex facility for handling, treating, conditioning the gas or oil, and capacity saying 2 mega barrels per day. This is about 1 day use over Korea, whole country. So it's a big scale project. And LNG FSRU is very similar to FPSO. Slightly different is for LNG. So they need to have a regasification unit. So similar to land-based LNG storage facility, but it is ship type and barge type. There are two different types. Sailing yacht. So, it is also lounge is most important one. Dining room and navigational space. This is most important one. Then there is a stateroom. There's a stateroom and guest accommodation, and then the engine is in the middle. So arrangement, I'm trying to show you how, as a designer, ship designer, you need to have arrangement. Let's see another video for sailing yacht. It looks like a big one. Let's see. Interior. It is above the deck. No engine room. Let's skip over this. The final slide. This is multi-yacht, already see. So also the most important place is lounge, dining room, and galley, and owner's stateroom, guest accommodation, right? And navigation bridge, crew accommodation. Right. Engine room is in the middle. Because usually small ships, they need to have an engine in the middle. Big ships is you have a freedom to locate engine because the engine is relatively large comparing to the size of the small ship. All right, that's it for the second part. And then we can have a short break and then have a discussion created by using